In this lesson, I just wanted to talk briefly about finding the inverse of a domain-restricted function. So in this example, we have f of x equals x squared plus 2, but we only want to look at it if x is greater than or equal to 0. So the question should be, why do we need that extra piece there to say that x is greater than or equal to 0? Well, if we look at the graph of f of x equals x squared plus 2, so plus 2 on the outside means it would be shifting up 2. It takes the shape of a parabola. Well, if we're talking about inverse, remember in order for a function to have an inverse, it has to be 1-to-1. In order for it to be 1-to-1, we test it using the horizontal line test. Well, if I draw a horizontal line through this parabola as it is, it fails the horizontal line test because it crosses in two places, which means that the function is not 1-to-1, which means it can't have an inverse. As a result, we sometimes have functions that have a domain restriction, as we can see here, of x is greater than or equal to 0. Because if we're only looking at this function f of x equals x squared plus 2, but only the positive x's, or x is greater than or equal to 0, then this graph essentially would be cut in half. So we're still going up 2, but we're starting at 0 and just taking the right side of that parabola. Now here we can find the inverse of this since it passes the horizontal line test. If I draw a horizontal line anywhere, we can see that it's only going to be crossing in one place, so that means the function is 1-to-1, so we can find an inverse. So our first step in finding the inverse of this function is to change f of x to y, so that we have y equals x squared plus 2, and that x is greater than or equal to 0 will just kind of hang out for right now. Our next step after we change f of x to y is to switch x and y. So from here, that means that we're switching all of our x's and all of our y's. So we're going to have our y would become x equals, rather than x squared, we're going to have y squared plus 2. But then this is where that restriction comes in, is that now rather than having x is greater than or equal to 0, we're going to have y is greater than or equal to 0. After we switch x and y, we do want to solve for y. So for right now, the y is greater than or equal to 0. We'll just kind of hang out. We want to follow our steps for solving for y for our equation. So I'd move the 2 over, so we have x minus 2 equals y squared. And then our next part, we would have to take the square root of both sides. Now remember, when you're taking the square root, we need to take the plus or minus square root, so that we really have y is equal to the plus or minus square root of x minus 2. Now that step is important with the plus or the minus, and then this is where that domain restriction comes into play, is because in order for this inverse to work and to be the true inverse of that domain restricted original f of x function, we only want the part that satisfies this restriction for our inverse function. So we only want the y's that are greater than or equal to 0. Well, looking at our plus or our minus, that would mean that we're only going to be taking the positive square roots. So really, we have that our inverse, which remember we rewrite as f with a -1, f inverse of x is equal to the positive square root of x minus 2. And that would be the only answer, because it satisfies that restriction that y has to be greater than or equal to 0. If we look at it in terms of the graph, remember that our original domain restricted function was up 2 and about half of a parabola. Now our answer for our inverse, a minus 2 underneath the radical, means that we're going to be shifting to the right 2 places. So right 2 places means that we would have like this. And then it should reflect over that y equals x, which it looks like it does. So the restriction is important in order to make sure that your final answer is accurate, because if from the beginning we had that x is less than or equal to 0, that means when we substituted in and switched x and y, we would have y is less than or equal to 0, which would mean that we would actually want the negative square root of x minus 2. So this would be your final answer.